Okay, Leslie, Kamari, Kamani. Uh, Judging by the class's reaction today, I think yesterday's or yesterday, I think yesterday's lesson was a bit of a struggle for everybody. So I thought we would review and maybe look at it a little bit different way. So we're going to talk again about mixed numbers and how we can decompose them. To first start by taking a look at these wedges here, and I want you to think first of all, how many sixes? Sixth. How many sixths do we have here? One, two, three, four, five, six, right? So we could call this 6/6, right? And then we see that we also have one whole circle, don't we? So those 6/6 make one whole circle. So 6/6 is also equal to 1. Remember we talked about that yesterday. Any fraction where the numerator and denominator are equal, that is equivalent to 1. That equals 1. Okay? Just want to review that really quick. Now, um, let's take a look at what we got here. Let's just count. We got 6/6 here, but then we bought another fraction over here. We got 4/6 here. So how many total sixths do we have? We got 6 and 4. That's 10, right? 10/6. Remember what we call this, an improper fraction, when we have a numerator that's greater than the denominator. So this is an improper fraction. But we can also look at it this way. We said that this is one whole circle, right? So we've got one whole circle, well, that's 1. And then what else do we have over here? 1, 2, 3, 4, 6, right? So we could say that 10/6 and 4/6, or 10/6 and 1 and 4/6 are the same thing, right? They're equal. Now let's use that knowledge to decompose 1 and 4/6. All right. Well, let's put this over here just to remind ourselves that we do have 10/6, but we're going to look mainly at 1 and 4/6. We're going to look at it as a mixed number, not an improper fraction. Now you want to think, how can we decompose this? Well, let's just look at the wedges. How about we got 6 here and we got 4 here? 6/6 plus 4/6. That's easy enough. Well, how about if what if we decompose it a different way? What if we break it up like this? We could say we got 3/6 plus 3/6 plus 4/6. That works. Or we could just to see how we can put it in groups. Maybe, we can take all the sixth but one. We got one here by itself and then add all these. So we could say 1 and 4/6 equals 1/6 right here. So 1 and 4/6 equals 1/6 plus how many 6 do we have here? 1, 2, 3, 4, 5, 6, 7, 8. That ain't right. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1/6 plus 9/6, right? So these are all ways that you can decompose 1 and 4/6. But also think you could do this without the wedges, right? Just remember that 1 and 4/6, since 1 and 4/6 is actually equal to 10/6. So anytime you're decomposing this, you're actually decomposing this too. So really all you got to think about is what numbers add up to 10/6, right? So you could say this, 1 and 4/6 equals 5/6 plus 5/6. You could also say 1 and 4/6 equals, what else equals 10? 4/6 plus 10 plus 6/6. Or did we already do that? We already did that one. How about we could say 1 and 4/6 equals 3/6 plus 7/6. We could do that. All right. So there's all the ways that we could break down 1 and 4/6. Let's try a different one. Let's work with thirds. And let's think, how many thirds make a whole? Well, since they're thirds, there's going to be 3 parts to a whole, right? So we can say that this is 3/3, but we could also say that it's 1, right? Same thing. 3/3 and 1 is the same thing. So now what if we add on this fraction here? Now what do we got? How many thirds we got over here? 2. So we've got 2/3 over here. We got 3/3 here, and we got 2/3 here. Improper fraction is 5/3, right? Then again, 3/3 is equal to 1, so we could say we've got 1 over here, and we've got 2/3 over here. So we could say that 5/3 is the same as 1 and 2/3. So let's try decomposing 1 and 2/3. Well, we could start with 3/3 here and 2/3 here. 3/3 plus 2/3, that equals 1 and 2/3. And also remember, 3 plus 2 is 5. You could be thinking back over here. How about if we the way we grouped them to add them up, we could say 1 and 2/3. What if we move these guys over here? And so now we got 1 over here. 1/3 plus 1, 2, 3, 4, 5, 4/3 over here. 1, 2, 3, 4/3 over here. So 1 and 2/3 equals 1/3 plus 4/3. Or we could do, let's say, 1/3 plus 2/3 plus 2/3. So we could say 1/3 equals 1/3 plus 2/3 plus 2/3, like that. All right, and again, remember, we could even just not use these, because look, remember that 1 and 2/3 is the same as 5/3, so we could just remember what numbers add up to 5. Well, 1 and 2/3 equals 3/3 plus 2/3. 3 and 2 is 5. 1 plus 2 plus 3, that's 5. So 1/3 plus 2/3 plus 2/3 equals that. I also know 1 plus 4 equals 5, so we could say 1 and 2/3 equals 1/3 plus 4/3, right? Okay, one more. Remember, after this, you need to be looking for an assignment in Seesaw. So let's work with sixths. No, fourths. We already did sixths. These are fourths. How many fourths make one whole? 1, 2, you should already know. 3, 4. So that is 4/4. And 4/4 is also 1. Because you see we got one circle here. We got 4/4. And then when we put them all together, they combine to make one circle. One whole circle. Well, so we got one whole. Let's add on a fraction. We got, what do we got here? We don't have a whole circle. We got 1, 2, 3/4 of a circle. So we've got 1 and 3/4. Well, first of all, let's do our improper fraction. 1, 2, 3, 4, 5, 6, 7, 7/4 is our improper fraction. And then for the mixed number, don't think of this as 4/4 now. Think of it as 1. So we got 1, and what we got here? 1, 2, 3, 3/4, 1 and 3/4. So how can we decompose this? Well, 1 and 3/4 equals 4/4 here plus 3/4 here. And then also think, so 4 and 3 makes 7. So what else makes 7? I know 5 and 2 makes 7. So we could do 1, 2, 3, 4, 5/4 over here plus 2/4 equals 7/4. And of course, we could do it different ways, like 2/4 plus 2/4 plus 3/4. That would work, right? What about all unit fractions? Each fraction by itself, right? 1, 2, 3, 4, 5, 6, 7 unit fractions. 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4. I don't write it here because it's too long and it takes up too much space, right? But that's definitely another way that we could decompose 1 3/4. So hopefully these wedges make it more visible to you so you can see what we're talking about when we have a mixed number and how we can decompose it. Hopefully this visual model makes it more simple and more clear. All right. So be on the lookout for another assignment in Seesaw. Okay. Talk to you later.